Welcome to myprojectbazaar.com. Our project title is an efficient model for screening differentially expressed genes of breast cancer based on LR. Let's see the abstract. Breast cancer is the most common cancer in women worldwide. Across the globe, breast cancer is the second most common type of cancer and the second leading cause of cancer death in women. One of the important tasks of gene chip profiling data analysis is to screen for differentially expressed genes. For example, by comparing the differences in gene transcription and expression between normal and disease states in the study of the pathogenesis of the disease, doctors can conduct early diagnosis and treatment of the disease and even predict the prognosis for patient. Currently, those methods suitable for different study design and data type gene expression profiles to screen differentially expressed gene for gene expression profile include significant analysis of microarrays and 2 sample t-test, base moderate t-statistic methods, and so on. However, false positive of the differential expression genes by using the significance analysis of microarrays sample t-test are too high. Actually, earlier researchers have tried to select differentially expressed genes by logistic regression. And in our proposed system, we are going to use logistic regression for test and train our dataset. And this is our flow of the process. First, we have to load the dataset, and the second step is normalization of the data. Here we normalize our dataset and we split our dataset into train and test. After splitting, we have to find out the differentially expressed gene selection. So here differentially expressed genes selection will be done by logistic regression, and we'll fix the higher than threshold. Here we'll fix the threshold, and this threshold will be calculated for lower score gene and differentially expressed gene. Let's see the running process. First, click on home.java. Right click on it and click run file. So this is our index page. We have to click on this image for the next page, and this is for loading our dataset. First click on the browse button. Select the dataset. So here I am selecting the cancer.csv file and opening it. After selection, it will load into our database, which is in the backend. So this is our database content. Here you can see some integer and float value are there. So the next step is we have to normalize those data. So click on normalize data, and now you can see the data will be normalized. So this is the normalized data. So all will be converted into integers so that we can easily give the input to the logistic regression. So this is our normalized and final data set. And click on go. And the next step is split train and test data. So click on train and test, and if we click on this button, this will split up the data set into 2, which is training data set and testing data set. So training data set will contain the data set 70% element, and testing data set will contain 30% of element, and we'll click on show. So this is our training data set, and this is our testing data set, and click on next. And we'll click on the splitting train and test. Here we'll give the logistic regression. So here you can see the regression iteration. Now here I was used 3000 iteration, so the iteration will be done. And this is the training dataset content and the prediction, and the testing dataset prediction will be presented here. So here you can see the average importance and gene ID. So this is the average importance which will be predicted by logistic regression. And next step is finding the top elements, finding top differentially expressed genes. So now I am giving 10 here. So click on OK. Here you can see the average importance and gene ID of top 10 differentially expressed genes. So this is the gene ID and the average importance for that particular gene ID. Thank you for watching.